So, 7th graders, today we're going to find out the missing sides using two different methods. The first method is called the shadow method because we're talking about triangles that uses the sun's rays. So for the moment, we're assuming that these two triangles, the one with the Eiffel Tower and the one with this little guy right here, we're assuming that these two triangles are similar. For these two triangles to be similar, they have to have congruent parts, equivalent ratios, and the scale factor. We're going to show the scale factor to solve this one. So let's assume that these sun's rays are parallel. Okay. We're trying to find the height of the Eiffel Tower. The shadow of the Eiffel Tower is 500 units. The height of the person is 6 units, and their shadow is 4 units. And again, the sun's rays are parallel. So, if we're looking for the scale factor, that means 4 times some number gave us 500. So in class what we do is we divide these two numbers. 500 divided by 4, and that comes out to be 125. So the scale factor is 125. To go from here to here, we multiply by 125. So that means 6 times 125, that's 750 units. Because we know what the scalar factor is, we know that the Eiffel Tower is 750 units tall. Let's use another method. This time we have a flagpole. It's X units long. It makes a shadow. Oh no, this isn't the shadow one. This is the mirror triangle. So what happens is that right here, there's a mirror on the ground. The idea is that a person standing right here, assuming they're perpendicular to the ground, can look at the mirror on the ground and should be able to see the top of the flagpole. Because of this angle is the same as that angle. They're congruent angles. This person is perpendicular to ground just as this person is perpendicular to the ground. These two are similar triangles because they have corresponding parts, corresponding sides, corresponding angles. In this method, we're going to use equivalent ratios to solve it. We can use scalar factor, but I just want to show equivalent ratios with this one since we use scale factor with the shadow triangles. So with the mirror triangles, let's see. The equivalent ratio we have is 6/10. We need 6/10 to correspond to the flagpole triangle, which would be x/90. Well, using equivalent ratios, we know that 6/10 is the same thing as 0.6. And so like we did in class, 0.6 times 90 happens to be 54. So that means the flagpole is 54 units tall. Again, this only works because we have two similar triangles, because looking at the mirror on the ground, we can see the top of the flagpole. That gives us the same angle measures here. And this person's perpendicular to the ground. The flagpole is perpendicular to the ground. Any questions? Okay. Good luck.